Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture we are going to know about the IUPAC nomenclature for coordination compounds. The International Union and Pure Applied Chemistry, that is the IUPAC, recommended the few rules for writing the systematic names of these coordination compound. So in today's lecture we are going to discuss about the 11 different rules that is recommended by your IUPAC for writing the nomenclature of the coordination compound. So this video will be the lengthy video. So I request you to kindly watch this video till the end, and this video will be useful for 12th, for all BSc students and for all MSc students. Here we are going to discuss each rule in detail in the stepwise manner along with its example. So now let us discuss about the rule number first, that is the order of naming the ions. Now in this rule we are going to consider the two simple points. So let's start with the point number first. In the ionic complex, the cations are named first, then the anions. In both positively and negatively charged coordination compounds, ionic complex consists of the two parts. One is the normal ion and the second one is the complex ion. Let us consider the example regarding this point. So here I have taken the two different examples. So the first example, that is K3FeC2O4 3 times. This is the coordination compound. Now this coordination compound is made up of the two different parts. This K3 is actually the cationic part, or it is also known as a normal ion, and the central metal atom along with the ligand in a square bracket is actually the anionic part in this complex ion, because we know that when we ionize this coordination compound we will get the K plus FeC2O4 3 times 3 minus complex anion. So this is the cationic part, as it is having a positive charge, and this whole complex ion have the negative charge, hence it is anionic part. Our rule first says that generally whenever you have to write the IUPAC name of this compound, we must write the name of the cationic part first. Hence I have written the potassium name first and then the anionic part, that is trioxolatoferrate oxidation state +3. Now let us consider the second example. The anionic part is actually the sodium. Hence I have written the name sodium first. Then it is followed by this anionic part, that is dicyanoaurate. We know that it will dissociate into the Na plus ion and AuCN2 minus ion. So that will be the complex anion and this will be the cationic part. Hence our rule says that we must write the name of the cationic part first, that is your here sodium, and then the next one is your dicyanoaurate. Now let us consider again the few examples regarding this one. Let us consider the third example, that is CONH3 6 times Cl3. So we know that this complex when dissociate, it will dissociate into the CONH3 6 times +3, which will be your anionic part, or it is known as a complex ion, and the 3Cl minus is actually the anionic part, or it is a normal ion one. Hence whenever we have to write the name of this compound, we must write the name of this cationic part first. Hence I have written the name as an hexamine cobalt, then the oxidation state 3, and it is followed by the name of anion, that is your chloride. So this is hexamine cobalt oxidation state 3 chloride. The fourth example, that is PT Br2 NH3 4 times Br2. So when this complex anion is dissociate, it will dissociate as an PT Br2 NH3 4 times +2 Br minus ion. So this will be your complex ion and that will be your normal ion. Hence we know that this complex ion is a cationic part in this anionic complex one, and this Br2 is actually the anionic part, or that is your normal ion. Hence its name should be start with the cationic part first. Therefore I have written this name as a tetramine dibromo platinum oxidation state 4, and then followed by the anionic name, that is your bromide. So this is about your point number first in the rule number first one. Now the point number second in the rule number first, In the non-anionic complex or a molecular complex, the name of this coordination compound is written in a one word. Non-anionic complex is that complex which do not contain any complex ion and a normal ion. So now let us consider the example regarding this one. Again, I have taken the two different examples. The first one is CONH3 3 times, NO2 3 times. As this complex will not dissociate into its complex ion and a normal ion, hence it is a non-anionic complex. And our rule says that its name must be written in a one word. So there will be a no any space between these ligands and the central metal ion. So here I have written this name as a triamine, trinitro, cobalt and its oxidation state +3. That's it. Now NiCO4, the second example. So here this is actually your molecular complex. So here again I have written this name in a one word, that is tetracarbonyl nickel and its oxidation state 0. So that is our point number second in rule number first. Now here you must note that the name of these coordination compounds is always start with a small letter, while the name of the complex ion is always written in a one word. Now here you can observe the four different examples that we have already considered, and you can observe that I always start the name of this coordination compound with a small letter, and if it is start with the name of a complex ion, it start with a small letter along with just the complex ion as an one word without any space here. Now the rule number second, that is the naming of coordination sphere. You know that coordination sphere is a square bracket in which there is a central metal atom or ion along with the ligands one. So here the rule number second say that in the coordination compound the name of ligands are written first, then the name of central metal atom or ion. Now let us consider the example regarding this one. I have considered again the two examples. The first one is COCl NH3 5 times +2. It is a complex ion. So its name is actually written as a pentaamine chloro, cobalt and its oxidation state 3. So here you can observe that I have followed one sequence in which I have written the name of this ligand first, that is pentaamine chloro, and then the name of your central metal atom or ion, that is your cobalt one. So that is our rule number second, says that you have to write the name of ligand first and then the name of this central metal ion. So again here you can observe that in the second example, that is COH2O NH3 5 times I3. So here again I have followed the same sequence. I have written the name of this central metal ion first, that is pentaamine aqua. So these are actually the ligands one. So their name must be written first. Okay. So these are the name of ligands and its name must be written first. Then followed by the name of central metal ion, and this is your normal ion. Hence it is written after writing the oxidation state of this central metal ion here one. So this is your rule number second regarding the IUPAC nomenclature of these coordination compounds. The rule number third, that is the naming of ligands. Now here let us consider first rule regarding the negative ligands, or it is also known as an anionic ligand. Name of anionic ligands or the negative ligands which ends with the suffix IDE, ATE, ATO is obtained by replacing suffix E by O, that IDO, ITO and ATO. So here I have shown this table for all the negative ligands one, their actual name, then their formula, then the charge on it and its name after replacing the suffix E by O. So this video will be very lengthy video if I explain all these names. So I request you to kindly take a screenshot of this one, put all these examples simply by writing it. So this will be very useful. Here I have taken approximately the 20 different negatively charged ligand along with their names. Now the point number 2 in the rule number 3. The names of positive ligands is always end with the suffix IUM. So here again I have shown the table in which I have taken the 3 different examples. So I request you to kindly write down these examples. So that is our point number 2. Now the point number 3 in the rule number 3. The neutral ligands or the organic free radicals have no any special ending. Their names are generally written as usual without any special suffix. So here again I have shown these examples. Kindly write down all these examples one. So here you can take the first example in this chart. So its name is ethylene diamine, and while writing the IUPAC name of this coordination compound, you can write down this name as an ethylene diamine as usual. However, there are few exceptions while naming the neutral ligands. That is, they have a special naming. So here the first example, you can observe that water is known as an aqua. Amine is written as an amine, but its spelling is different. Here we have to use the double M in the name. Now next, carbon monoxide, that is your CO, which is known as an carbonyl. So these are the few special names that is used while writing the name of these exceptional ligands one. So this is about your rule number 3. Now the rule number 4, the order of naming ligands. Here the ligands are named in the alphabetical order irrespective of their nature. That is, they may be positively charged, they may be the negatively charged, or they may be the neutral or the free radical ligands. Here we have to just follow the alphabetical order. While the prefixes di, tri, tetra, etc. are not considered for naming in a alphabetical order. So let us consider the examples here. I have taken this example, that is PT NH3 4 times Cl NO2 SO4. So I have written its name as an tetramine chlorido nitrito platinum oxidation number 4 sulfate. So here actually I have considered the alphabetical order while naming these ligands one, and this alphabetical order is, we know that alphabetically A come first, then C, and then N. So you have to follow the alphabetical order while writing the name of all these ligands. We are not going to consider the nature of this ligand, whether it is a neutral or negative or maybe the positive ligand. We will directly follow the alphabetical order while naming all these ligands one. Again remember that we are not considering the prefixes first alphabet for writing this name of these ligands one. Okay, so that is our rule number 4. Now the rule number 5, that is prefixes used to indicate the number of ligands. So point number 1, when 2 or more simple ligands are present, then the simple prefixes such as di for 2, tri for 3, tetra for 4, penta for 5, so on is used to indicate the number of ligands present in the coordination compound. Now let us consider the example regarding. I have taken the 2 different examples. So here you can observe that there is a 2 chlorine and the 2 ammonia ligands present in this example. So while writing this name, I have followed the alphabetical order. Along with, there is a 2 times ammonia, hence I have written the prefix di for this one, and again there is a 2 times chloride ligand, hence I have written the prefix di before writing the name of these ligands one. Now the second example, again you can observe that there is a 2 chloride ligand and the 4 ammonia ligand. While writing the IUPAC name of this coordination compound, so here I have written the prefix tetra, tetra for 4, then the name of ligand, that is amine, then chlorine is a 2 times I have used the prefix di, then you can write it as an chloro, or in 2004 the IUPAC nomenclature recommendation says that you can write the name of this chlorine as an chloride also. So if you use the chloro name, it will be also acceptable. Then the platinum oxidation state 4 and the ion as it is in the anionic form 1. The point number 2 in the rule number 5. Chelating ligands or the complex ligand which having the prefixes in a name itself, then while naming these ligands a special prefixes such as bis for 2, tris for 3, then tetrakis for 4 and pentakis for 5 and so on are used before writing the name of these ligands. And whenever we are going to use a special prefixes, the name of that ligand is always written in the parenthesis. So let us consider the example regarding our point number 2 in the rule number 5. So here again I have taken the two different examples, that is COCl2 En2 2 times, that is your ethylene diamine ligand, then Cl2, and the second example is your COEn 3 times Cl3. I have written this name by following the alphabetical order. So there is a 2 times chlorine, hence it is a dichloro, or you can write it as a dichlorido. But we know that ethylene diamine already have a 1 prefix, that is the diamine. Hence we cannot use the simple prefixes, we are going to use a special prefixes here. So bis is the prefix which is used before the name of these ligands, and these name of ligands are written in the parenthesis. So therefore its name will be the dichloro bis ethylene diamine cobalt oxidation state +2 chloride. In the second example, here the ethylene diamine is present 3 times, hence we have used the prefix tris, tris for 3, tris ethylene diamine in the parenthesis cobalt oxidation state +3 chloride. So this is the simple rule which is used for naming the complex ion or the ligand in which in the name itself have already the prefix. Hence we have to use these special prefixes such as bis, tris, tetrakis and so on. Now the rule number 6, that is the naming of complex ion and the naming of central metal atom or ion. So here let us consider the first point. When the complex ion is having a negative charge, that is if it is the anionic complex, then the name of central metal ion or atom ends with the suffix ate. Now let us consider the examples regarding this one. Here I have taken again the two different examples. You can observe that K, Pt, Cl5, NH3. So here if I dissolve this complex, you will get the potassium plus ion, that is K plus, and the anionic complex ion as an Pt, Cl5, NH3 minus. So it is an anionic complex ion. Hence the name of this central metal atom or ion ends with the suffix ate. Hence I have written the name of this compound as a potassium amine pentachlorido platinate instead of platinum and the oxidation number 4. So the name platinum changed to platinate. So here I have used the suffix at. Now let us consider the second example, that is Ca2Fe Cn 4 times. So if I dissolve it, you will obtain the 2 Ca plus 2 ion and the anionic complex ion as an Fe Cn 4 times 4 minus. Hence as it is the anionic complex, the name of central metal ion ends with the suffix at. So hence I have written its name as an calcium hexacyanoferrate oxidation state +2. Now here again I have shown one table in which I have written the names of metal ion, and if that metal ion is present in the anionic complex, its name should be written in such manner. So let us consider the few examples, because this table is a very important one. I request you to kindly take a screenshot and actually write down these names one. It will be useful for you. So here if I consider the gold, so gold have a special name as an aurate. You cannot write it as an goldtate. Okay. Then next iron, iron is written as an ferrate. Then next lead, lead is actually written as an plumbate. Then the next, that is your silver. Okay, so silver is actually written as an argentinate. Then next tin, tin is written as an stannate, and zinc is written as an zincate. So these are the few important names that you must know, which is used for the central metal atom or ion when they present in this anionic complex. Now the point second for our rule number 6. For cationic complex or a neutral complex, the name of central metal ion is written without any special suffix. So let us consider the example regarding this one. So here you can observe that this complex is having a cationic complex, that is FeH2O6 time plus 2. Hence its name is written as an hexa aqua iron. So it is not written as an ferrate or something else. It is directly written as an iron oxidation state plus 2 sulfate. Now let us consider the second example, that is PtCl2NH3 2 times. Again you can observe that I have written its name as an diamine dichloroplatinum, as there is no any complex ion here. Hence it is a neutral complex and its name is end without any suffix or anything else. So that is your rule number 6 regarding the name of the central metal atom or the ion, including the name of your complex ion. So now let us consider the rule number 7, that is the oxidation state of central metal atom or ion. Now let us consider the point number first in it. The oxidation state or the oxidation number of the central metal atom or ion is written in a Roman numeral in a parenthesis after the name of the central metal atom or ion without any space. So let us consider the examples regarding this one. So here I have taken again the two examples. Now PtCl NO2NH3 4 times SO4 is the first example. So here I have written the name as a tetramine chloronitrito platinum. So that is the name of your central metal atom or ion, and its oxidation state is 4, which I have written in a Roman numeral and in the parenthesis. Sulfate is the rule that we must consider. The second example, again here I have taken it as an K3Al C2O4 3 times, and its name is written as an potassium trioxolato aluminate. So this is actually aluminate is the name of your central metal atom, and its oxidation state is written in a parenthesis in a Roman numeral as a 3. Now point second for rule number 7. If the oxidation state is a 0, so 0 is written in the parenthesis, and if the oxidation state for the central metal atom or ion is a minus, then we have to put a minus sign before the oxidation state in a parenthesis. So let us consider the example regarding this one. So here I have taken again the two examples. So first one is a FeCO5 times, and its name is written as a pentacarbonyl iron, and its oxidation state is written as a 0 in a parenthesis. Now the second example, that is NaCO2 4 times, and its name is written as a sodium tetracarbonyl cobaltate, and its oxidation state is 1, but it is a -1, hence I have put this sign minus here. So this is the simple point that you must note here. So this is about your rule number 7. If you are unable to calculate the oxidation state for this coordination compound, I will give you the link for that video, how to calculate the oxidation number for these complexes compound. Kindly watch that video also. Number 8, that is the naming of bridging ligand. Ligand which act as a bridge or which connect the two central metal atom or ion known as a bridging group or the bridging ligands. The Greek letter mu is written before the name of these bridging ligands. The Greek prefix mu is repeated before the name of each kind of the bridging ligands. Now let us consider the examples regarding this rule number 8. So now here I have taken the two different examples. You can observe here. So these two groups which connecting the two central metal atom, they are known as bridging ligands or the bridging groups. So its name is written as we are going to put a Greek prefix mu before the name of this ligand. So mu amido, then mu nitrito, because both are acting as a bridging ligand. Then mu nitrito N, we will see this rule later on. Then octaamine, 4 plus 4 total 8, hence it is a octaamine dicobaltate, as there is a two central metal atom, hence it is the prefix we usually use as a simple prefix, that is dicobalt. Then the nitrate, and we have mentioned after the cobalt its oxidation state. That's it. Then the second example, here again you can observe that there is a total 4 ethylene diamine molecule, the 2 cobalt and the 2 bridging groups. So here again I have written this name as mu hydroxo, as this is the group which is your hydroxo group, or you can consider it as an hydroxyl group also. Then again the mu amido, then tetrak is ethylene diamine dicobalt oxidation state +3. So we have put the Greek prefixes mu before these bridging ligands. So that is our rule number 8. Now the rule number 9, that is the point of attachment. If the ligand contain the 2 or more donor atoms, if the ligand is coordinated through only one donor atom, then the point of attachment of that ligand is indicated by putting the symbol of that donor atom after the name of that ligand. So let us consider simply this point. So here I have taken the nitrito group and the thiocyanate group. So nitrito group, if it is coordinated through nitrogen atom, then it is written as an NO2 minus. So you are going to write the name as an nitrito N. So we are putting the symbol of that donor atom which is coordinated to central metal atom or ion. Again, if in the nitrito group the nitrogen atom is coordinated through oxygen atom, then it will be written as an ONO minus, and its name is written as an nitrito O. So in the nitrito group there is a 2 donor atom, nitrogen and oxygen, and if it coordinates through nitrogen atom, we are just putting the symbol of it one after the name of this ligand, and here also we are putting the symbol of oxygen atom after writing the name of this ligand. Now let us consider the second, that is your thiocyanate group. So it can be coordinated through sulfur and the nitrogen atom. If it is coordinated through sulfur atom, then its name is written as an thiocyanato. Yes, so we are putting the symbol of sulfur here. And if it coordinates through nitrogen atom, then its symbol is written as a nitrogen here. That's it. That is thiocyanato N here. So this is your rule number 9. Now let us consider the example regarding this one. So here I have taken the two different examples regarding the rule number 9. So here I have written the name of this complex as a triamine nitrito N. That means this nitrito group is coordinated with this central metal atom through nitrogen donor atom, and lastly the central metal ion name, that is cobalt, and its oxidation state. Again the second example, that is your COONO then NH3 times SO4. So here I have written its name as an pentaamine nitrito-O. So actually this nitrito group coordinated to cobalt central metal atom through oxygen atom, hence its name is written as an nitrito-O. Then the name central metal ion, that is your cobalt, oxidation state +3, and lastly this sulfate. Again remember one important point, if the sulfate is the 2 times, we never mention the disulfate here, no need to mention this one. So we are not going to consider any prefixes for your cationic or the anionic entity for this ions one. This is about your point number 9. Now next, rule number 10, that is the naming of geometrical isomers. Geometrical isomers of your complexes compounds are generally named by the cis and the trans form. The term cis is used to designate the adjacent position of the same ligands, while the term trans is used to designate the opposite position of these ligands. Now let us consider the example regarding this rule. So here I have considered the 2 different examples. Actually these are the 2 examples, but you can here observe that 2 ammonia ligands are on the same side, hence it is a cis isomer, hence its name is written as an cis diamine dichloroplatinum oxidation state 2. And here you can observe that the 2 ammonia molecules are on the opposite side, hence its name is written as trans diamine dichloroplatinum oxidation state +2. So simply we have to mention whether it is a cis or the trans isomer. The rule number 11, that is the naming of optical isomer. The dextrorotatory and the levorotatory optical isomers are named by designating small d or plus sign or the dextrorotatory isomer, or a small l or minus sign for the levorotatory isomer. Now let us consider the examples regarding this one. So here it is the dextrorotatory complex compound or the coordination compound, that is K3IRC2O4 3 times. Hence its name is written as an potassium small d, or you can write a plus sign also, trioxolato iridate oxidation state 3. So this is your rule number 11. So these are the different 11 rules that we have studied for the systematic nomenclature of your coordination compound or the complex compounds. Hope you will like this video. Thank you so much for watching this video. See you in my next video.